students, chapter 7 AC current. Yes, in last lecture we have discussed about resonance. What is condition of resonance? Yes, at particular value of angular frequency, that is omega 0, XL is equal to XC in Lcr Series AC Circuit, impedance becomes minimum and amplitude of current becomes maximum. Then what is sharpness of resonance? What is quality factor? What is used? Yes, it is used in tuning of circuit. That we have discussed. Now in this lecture we will see power in AC circuit, the power factor. See, for Lcr Series AC circuit, we know that instantaneous value of AC voltage instantaneous values of AC voltage V is equal to Vm sin omega t, and AC current I is equal to Im sin omega t minus k, where Im is equal to Vm upon under root r square plus xl minus xc whole square, and phase difference del is equal to tan inverse xl minus xc upon r. Okay, yes, we know this. Now instantaneous power in circuit, instantaneous power in circuit. What is instantaneous power in circuit? Yes, we know that. What is equation of power? Power P is equal to, it is VI. Power P is equal to, it is VI. Then what is equation of instantaneous power? Yes, power P is equal to, it is VI. What is value of V? Vm sin omega t, Im sin omega t minus k. Okay, so yes, I will write this equation as P is equal to, it is Vm Im, here it is sin omega t minus del, okay, sin omega t. Yes, I will divide this equation by 2 and multiply this equation by 2. Okay, then see what happens to this. Vm Im divided by 2. This 2ss means it is one mathematical equation, okay, that you have to remember. 2ss is equal to, it is c minus c, where in first cause you have to take subtraction of this two angle, that is omega t minus del minus omega t. Okay, this angle minus this angle. In between there is minus sign. Now you have to add this angle, that is cos omega t minus del plus omega t. Clear about this? So now how to simplify this? That is average power P is equal to, average power P is equal to, it is Vm Im divided by 2. In bracket we have, it is cos. See, omega t minus omega t cut, so it is cos minus del minus cos, here it will be 2 omega t minus a. Clear about this? So yes, it is equation of instantaneous power. It is equation of instantaneous power. P is equal to Vm Im divided by 2 cos minus del minus cos 2 omega t minus del. Okay, yes, it is instantaneous power, and I can also write this equation as therefore P is equal to Vm Im divided by 2 cos del minus cos 2 omega t minus. Okay, it is instantaneous power. If we find power average average power over a period. Now average power over a period. Average power over a period. Then what is average power over a period? See, average power P is equal to, average power P is equal to, it is average of this whole equation, and I can write this whole equation as Vm Im by 2 cos del minus Vm Im by 2 cos 2 omega t minus del. Okay, so yes, therefore average power P is equal to Vm, that is maximum value of voltage constant, Im maximum value of current constant, 2 constant, cos del, that is phase difference, it does not depend on time. Yes, Vm, Im, cos del, they do not depend on time, they are constant. So yes, their averages is Vm Im divided by 2 cos del. While here Vm Im upon 2 constant, but cos 2 omega t minus del, cos 2 omega t means cos function depends on time, and yes, we know that whenever cosine or sine they depends on time, their average over a period it becomes 0. So here what is equation of average power? Yes, equation of average power P is equal to, it is Vm Im divided by 2 cos del. Okay, also I can write this equation as P is equal to, it is Vm upon root 2, Im upon root 2, and here it is cos del, So therefore P is equal to Vm upon root 2, Vrms, Im upon root 2, Irms, and here it is cos del. Clear about this? Yes, Vrms is equal to, it is Irms into Z. So again I can write this equation as it is I square Rms into Z cos del. Clear? So yes, it is equation of power. That average power P is equal to Vrms, Irms, cos del. Vrms, Irms, cos del. What is del? Del is phase difference between voltage and current. Del is phase difference between V and I. There is phase difference between V and I. Clear about this? So yes, it is equation of average power in AC circuit. Okay? Yes, what is equation of power in AC circuit? Yes, average power P is equal to V RMS I RMS cos del. See, this power P does not depend only on Vrms or Irms. It also depends on del, that is phase difference. And we know that for different circuit, value of del is also different. For only pure resistive circuit, for only pure inductive circuit, for only pure capacitive circuit, value of del is different. And yes, therefore, this power, average power P over a period also varies from circuit to circuit. Okay, so yes, this power P depends on this phase difference also. Here power P depends on cos del, and this cos del is called power factor. Because according to this equation only, Vrms, Irms, if they are fixed for a given circuit, then yes, due to this cos del, that is power factor, power varies. Okay. Now what is power factor cos del? What is power factor cos del? See here, first of all, we will see some special cases. First, for pure resistive circuit, we know that for pure resistive circuit, phase phase difference between V and I, that is del, is equal to 0. And if in this equation if you put that cos del is equal to 0, cos 0, then power P is equal to it is V RMS I RMS, or you can say it is I RMS square R, and it is maximum power. It is maximum power dissipated in circuit. Clear about this? So yes, first case, for pure resistive circuit, phase difference between voltage and current, del is equal to 0. So power P is equal to V RMS I RMS, or you can also write I square RMS R. Okay, it is maximum power dissipated in circuit. Now for second, pure inductive circuit. Yes, we know for pure inductive circuit. Okay, for pure inductive circuit, I lags behind V by phase pi by 2, means del is equal to it is pi by 2, and if you put here value of del pi by 2, then cos pi by 2 will become 0. So therefore power P is equal to 0, means power dissipated is 0. Power dissipated is 0. And yes, in this situation, as power dissipated is 0, current flowing in this such circuit is called wattless current. Current in circuit is called wattless current. It is called wattless current. Clear about this? Now third one, that is pure capacitive circuit. Pure capacitive circuit. In case of pure capacitive circuit, see, in case of pure capacitive circuit, what happens? Here it is. In case of pure capacitive circuit, again we know that in pure capacitive circuit, I leads V by phase pi by 2. That is, del is equal to minus pi by 2. Okay, del is equal to minus pi by 2. So therefore, yes, del is equal to minus pi by 2, cos minus pi by 2, it will again become 0. So power P is equal to 0. So again, power dissipated is 0. Power dissipated is 0. Yes, power dissipated is 0. And again, in this circuit, current in circuit is called wattless current. Current in circuit is called wattless current. Is called wattless current. Clear? Okay. Fourth one. It is one general equation. Fourth one, that is for Lcr Series AC circuit. For Lcr Series AC circuit, cos del is equal to it is R upon Z. How R upon Z? Remember that analytical method. Cos del is equal to it is R upon Z. Cos del is equal to it is R upon Z. That you have to remember. Okay. Next one is number 5. That is Lcr Series AC circuit. Now for Lcr Series AC circuit, see, it is common equation of power factor. It is common equation of power factor. It is common equation of power factor. Now for Lcr Series AC circuit, at resonance, we know that XL is equal to XC, and therefore Z is equal to only R. See, here it is, XL is equal to XC, that means Z is equal to only R, and therefore cos del is equal to it is R upon R is equal to 1, and therefore del is equal to 0. Clear about this? Clear about this? Okay, cos del is equal to 1 and therefore del is equal to, it is 0. 0. Cos del is equal to 1 and del is equal to 0. So see, LCR series AC circuit at resonance, it behaves as purely resistive circuit. It behaves as purely resistive circuit. And in this case again, what is power? What is power? So yes, power P is equal to, it is V RMS I RMS, or you can say it is I square RMS R, and it is again maximum power. It is again maximum power. Clear about this? So yes, again this point is important. LCR series AC circuit at resonance, XL is equal to XC and Z is equal to R. So cos del is equal to 1. Okay, and del is equal to 0. So power P is equal to V RMS I RMS is equal to I RMS square R. That is maximum power. Okay. So yes, it is one important theory. Yes, it is one important theory. LCR series AC circuit. Okay, and in that, what is average power? Okay, clear about this? This is it for today. Now we will see some extra cases. See here. For AC circuit, let AC voltage V is equal to Vm sin omega t and I is equal to Im sin omega t minus k, or you can write Vm upon Z sin omega t minus k. Okay, V is equal to Vm sin omega t. Vm amplitude of voltage, Im amplitude of current, del phase difference between voltage and current. Del is phase difference between V and I. Okay, now first case, Lcr Series AC circuit. Yes, you have to remember these two values, first of Z and second of A. For LCR series AC circuit, impedance Z is equal to, it is under root R square plus XL minus XC whole square, and A is equal to tan inverse XL minus XC upon R. Okay, now from this equation you can derive equation for any circuit. See, for example, if I am taking only resistive circuit, then for only resistive circuit, yes, for only resistive circuit, XL is equal to 0 and XC it is also 0. So what is value of Z? Impedance, yes, impedance Z is equal to R. XL 0, XC R, then it is tan inverse 0. The tan for A is also 0. Simple. So for only resistive circuit, Z is equal to R and D is equal to 0. Here you have to put Z is equal to R and D is equal to 0. Clear about this? Okay. So yes, in this case you will get Im is equal to Vm upon R. Im is equal to Vm upon R. But what is Im? Yes, Im is equal to Vm upon Z. Clear about this? Okay. Now next one is number 3. Only inductive circuit. So yes, for only inductive circuit, R is equal to 0 and XC is equal to 0. Then see here, R is equal to 0, X is equal to 0, XL square and its square root. So yes, impedance Z is equal to, it is XL. Okay, what about this del? What about this del? So del is equal to tan inverse XL minus XC upon R, means 1 upon 0. 1 upon 0 means infinity and tan inverse infinity. So del is equal to, it is pi by 2. And yes, it will be positive. Clear about this? And yes, in this case, as Z is equal to XL, what is equation of current? Im is equal to Vm upon upon XL. Okay, now fourth case, only capacitor circuit. Only capacitor circuit. Then yes, in only capacitor circuit, R is equal to 0 and XL is equal to 0. Then here it is minus X equals square. So this X is square, 8 square root. So Z is equal to here it is XC. Okay, and again D is equal to it is 5 by 2 but negative. Okay, and here yes, what is value of Im? So value of Im is equal to it is Vm upon X. It is Vm upon X. Okay, so see, first of all, Lcr series AC circuit. Then individual, only R, only L, and only C. Now we will see combination. That is number 5. RL series circuit. RL series circuit. So yes, in RL series circuit, X is equal to 0. So in this equation of impedance, if you put X is equal to 0, then Z is equal to this under root R square plus XL square. Okay, if you put here X is equal to 0 and D is equal to here it is tan inverse XL upon it is XL upon clear about this? So yes, it is equation. Okay, and now what is equation of Im? Im is equal to it is Vm upon Z. Im is equal to it is Vm upon Z. Z means it is under root R square plus XL square. Under root R square plus XL square. Clear about this? Okay, so it is RL series circuit. Now next one is RC series circuit. RC series circuit. Chalo, RC series circuit. So yes, in RC series circuit, XL is equal to 0 because no inductor. Okay, so yes, XL is equal to 0. Then from this equation, we will get Z is equal to it is under root R square plus XC square, and D is equal to it is tan inverse minus XC upon R, or you can say it is minus tan inverse XC upon R. Clear about this? What is equation of current? Yes, equation of current. Im is equal to it is Vm upon under root R square plus XC square. Clear about this? So it is RC circuit. Last one is LC series circuit. Yes, in this LC series circuit, we will take two cases. Yes, in LC series circuit, first of all, R is equal to 0. And now we will take two cases. If XL greater than XC and if XC greater than XL. Then yes, in this case, what happens? See, if XL is greater than XC, in equation of Z, if you put R is equal to 0, then Z is equal to XL minus XC. So yes, here impedance Z is equal to it is XL minus XC. XL minus XC. And if you take R is equal to 0, del is equal to it will be positive. Del is equal to it is pi by 2 positive. And what is equation of Im? Im is equal to it is Vm upon XL minus XC. When XC is greater than XL, then what happens? Yes, Z is equal to it is XC minus XL. Z is equal to it is XC minus XL, and therefore D is equal to minus pi by 2, means it is negative. Okay, and yes, Im is equal to it is Vm upon XC minus XL. So see, yes, you have to remember only this equation, that is for Lcr series AC circuit. Yes, you have to remember equation only for Lcr series AC circuit. So see, you have to obtain equation, or you have to remember equation only for Lcr series AC circuit. From these two equations, you can derive this each and every cases. Okay, that is only R, only L, only C, RL series circuit, RC series circuit, and LC series circuit. Clear about this? Okay, so yes, it is all about these extra equations that you have to use to solve questions. Okay, so yes, this is it for today.